This video will present the visual proof of Pythagorean's theorem. I will use three visual demonstrations proving the theorem. The very first one is using 5 different colored pieces. These 5 pieces can fit in the square constructed on the hypotenuse of a right triangle shown here with the blue lines or segments. So this is a blue triangle, which is a right triangle, side A, B and C. C being the hypotenuse is the largest square, so I'm going to fill in the square C with these 5 pieces. Now these 5 pieces completely fills the square which is constructed on the hypotenuse. In order to establish the proof of the theorem, these 5 pieces, the area covered by these 5 pieces, should also cover the area of the 2 squares constructed on the leg of this blue right triangle. So I'm going to have these pieces, I will move these pieces and I will try to fill the other 2 squares. Like this one fills in here, I'm going to move this piece, will come and covers this partially, and the last piece is going to fit in here. Now I'm going to move the other 2 pieces to fill the area of the square constructed on this leg A, and you can see this fills in here. So visually it demonstrates that the area of the 2 square constructed on leg A and that on leg B is equal to the area constructed on the square at the hypotenuse. So these completely fill these the 2 squares, which proves the theorem. Now I can try one more time. These 5 pieces, they cover the C square, and it also covers the other 2 squares. So that is the Pythagorean theorem. It says that A square, the area of A square and area of B square is equal to area of C square. So that is one visual proof using these 5 tiles. Normally I give this particular activity to my kids in a computer lab, and I allow them to play with these 5 pieces and try to figure it out how these 5 pieces will cover the area of the square C as well as the area of the other 2 squares. Now I'm moving to the next one, which is this one. In here I have a red square constructed on its leg A, which has 3 by 3 size. It has 3 divisions. You can see 1, 2 and 3 and by 3. So this square has 3 by 3 squares, which is 9 squares, and the yellow one, which is constructed on the leg B, has 4, which is 1, 2, 3, 4 and this way also 4. 1, 2, 3, 4. So this square has 4 by 4. So if you count the number of squares in here, in the yellow one, which is the B square, there are 16 small squares, and on the red one I have 3 by 3 means 9 small squares. So the total is going to be 9 plus 16. There are 25 little squares, and those little squares, as per the theorem, must cover the area of the C square. So let us see how this is possible. So you can see here, I move this red square and I will unfold this, and it covers this side, and you can see that the 25 total squares cover the square which is constructed on the hypotenuse, which is C. So the length of the each side of this square, because there are 25 little squares, so length of this square is going to be 5 by 5, which I can count here. 1, 2, 3, 4, 5, and along this line of the side there are 5. 1, 2, 3, 4, and 5. So this is true that the square constructed on the hypotenuse, which is C square, has total 25 squares, and these 25 squares cover the other two square constructed on the two legs of the same right triangle. Now these numbers, as a numerical example, I can see the value of leg has A has 3 and leg B has 4 divisions. So which we saw, let me reset this, and this is the, so you can see there are 3 divisions on this side. A has 3 divisions and B has 4 divisions. The hypotenuse has 5 divisions upon relocating the two squares to fit in the C square. So the value, you can put the numerical value, which is 3 square plus 4 square equal to 5 square. So that is true. So that is 9. 3 square is 9, 4 square is 16, and 5 square is 25. So on each side of this equal sign we have 25 on one side, 25 on the other side, which makes the Pythagorean theorem true. So this is the second proof, visual proof. Now I'm moving to the third one. In this example, I have some red square constructed on leg A, which you can see there are, I'm going to count 1, 2, 3, 4, and 5. And on this side of this square there are 5. 1, 2, 3, 4, and 5. So there are 5 by 5. So there are 25 little square constructed on the leg A. Likewise, on leg B, there are, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. In this case, we have 12 here. So that means, let me write it, which tells this, that on A square I have 5, on this side I have 5 square, which is 25 little squares I have here, and this yellow one I counted 12 by 12, which I can write as 12 square, which is 144. So the total little squares in both these red and the yellow squares are going to be, I'm going to count the A square plus B square is going to be 5 square plus 12 square, which is going to be 25 plus 144, and that gives me 169. So the total squares is going to be 169. How these 169 squares are going to be arranged in the largest square, which is constructed on the hypotenuse C. So we are going to see how these 165 little square can fit in this, and if it fits in, that means the Pythagorean theorem is true. So let us try that one. I'm going to switch this. Let me reset. So if I fill I'm going to move this red one and I will open this. You can see when you open, so that comes in here, and the 144 little squares in the yellow squares, and there are 25 along with the side of this square. So I can count this like this. Let me count it. So this is 169. That means how many each side this square, the dimensions or the side of this square, the C square, should be what? So let us count it. I know it is 169 total. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And 13 are on this side. So this is 13 by 13, which makes it 169. So this is also this number is also shows that yes, it is the Pythagorean theorem is true. I'm going to rearrange one more time these 25 little squares, and then the yellow square comes in, and here is the explanation. In this case, the leg A has 5, which is the red one, and leg B has 12 divisions. The hypotenuse has 13 divisions upon relocating the two squares to fit in the C square, which is given calculation is here. 5 square plus 12 square is equal to 13 square, and when you count this, so both sides we get 169 and 169. That means the Pythagorean theorem is true. These numbers, like in this particular example, 5, 12, and 13, these numbers are called Pythagorean triples. It is very important information one should know. These are the numbers. And in the previous example, the important digits were 3, 3, 4, and 5. So that is the Pythagorean triples. Any number which satisfies the Pythagorean theorem, the whole numbers, those are called the Pythagorean triples. So these are the 3 different proofs. It is very important to learn some triples, which I am going to demonstrate in the next video, how you can generate the Pythagorean triples. I hope you understand the Pythagorean proof, and you will be able to use the Pythagorean theorem with ease.